Hello, dear students. Good night, madam. Yes, welcome back to the chemistry class. The last part, qualitative analysis. In qualitative analysis, we have completed carbon and hydrogens, right? Let's continue with the next part, nitrogen, sulfur, and halogens. Okay. Qualitative analysis. This qualitative analysis involves the detection of various elements present in the organic compound, right? Yes. The qualitative analysis of organic compound, which involves detection of various elements present in the organic compound. Carbon, hydrogen, nitrogen, sulfur, and halogens. How we are going to detect? Even phosphorus also. Phosphorus and oxygen. Detection of these elements. Detection of carbon, hydrogen, nitrogen, sulfur, halogens, phosphorus, and oxygen. These elements we need to detect the presence of these elements in the organic compound. The first two, carbon and hydrogen, can be detected by copper oxide test. So as you know that already, copper oxide test, how it is conducted and what is the observations. Simple, the organic compound mixed with the copper oxide and heated in a heating tube. So the liberated gases are made to pass through a delivery tube containing anhydrous calcium sulfate or copper sulfate. Copper sulfate, and the another end is dipped in lime water. So if the color changes from colorless to blue, that indicates water molecules are evolved. So water evolved means the compound containing hydrogen. Now the lime water turns to milky, that indicates carbon dioxide is present. So detection of carbon and hydrogens is completed. Now detection of nitrogen, second one, detection of nitrogen. So nitrogen can be detected by the following tests. Sodium fusion extract or Lesson test, soda lime test, are just by heating. Dry heating test, the first one is dry heating test. The first one, simple. So here, usually 3 columns. First one is experimental column. What is the observation and inference? So here, you need to do just heat first. Organic compound containing is taken. Organic compound containing nitrogen. When it is heated strongly, if it gives the smell of burning hair, smell of observation, burning hair, this indicates this is the observation, this is the experiment, observation, and inference. So here this indicates the presence of nitrogen is present. Nitrogen, the compound containing nitrogen is present. Simple experiment. So this is first one. Here compound, given compound, just you need to heat and check the smell. If it gives a burning air smell, that indicates nitrogen is present in it. Now the second one is soda lime test. Soda lime test. So here the presence of nitrogen, further it is confirmed by the organic compound mixed with the soda lime. What is the composition of soda lime? Soda lime, NaOH plus CO. So plus heat. In a test tube, organic compound plus soda lime and then heat. If it gives the smell of ammonia, ammonia. This indicates the presence of nitrogen in furnace. Experiment, we need to do this observation and inference. This is the second test. The third one is lessons test. Lesson test. Third, lessons test. Lessons test. Lesson test. Sodium fusion extract test. NaOH plus calcium oxide, CaO, soda lime. The mixture of NaOH plus calcium oxide is known as soda lime. Plus heat, organic compound plus soda lime and then heat. This is the procedure. Smell of ammonia. If you observe the smell of ammonia, that indicates the presence of nitrogen in the given organic compound. Next, lesson test. In lesson test, first step is preparations of lesson solutions. So we have prepared sodium fusion extract. So in this case, in third, the experiment, acidic sodium fusion extract plus, usually it is in basic medium, or you can add it to base and alkali plus. To this, freshly prepared FeSO4 solution is added. Freshly prepared FeSO4, heat and cool, and then heat, cool plus few drops of FeCl3, few drops of FeCl3. Test step by step. First, you need to take a test tube. 1 to 2 ml of SFE is taken in the test tube. Sodium fusion extract is taken in the test tube, and to this little 1 or 2 drops of alkali is added, and then freshly prepared ferrous sulfate solution is added. Heat the solution, allow to cool, and then add FeCl3, neutral FeCl3, ferric chloride solution, and then after it is acidified with acid, acidified or let acid. Acid is acidified. In this case, if this is the experiment, it is the experiment. In this case, blue or green color is appeared. Blue or green, greenish. Violet color, blue or green. Blue or green. This indicates the presence of nitrogen. If it is another color, which color it is? Blue or green? Blood red. If you are getting only blue or green, this indicates the presence of nitrogen. If you are getting blood red color, this indicates the presence of nitrogen plus sulfur. Same experiment, two observation. Perform the experiment and check out the results. If you are getting a blue color solution or greenish colored solution, that indicates nitrogen is present. If you are getting red blood color, then that indicates nitrogen along with sulfur is present in the compound. Nitrogen along with sulfur. Say next, this is a test for nitrogen. Nitrogen can be detected by these experiments. Yes, nitrogen is present. If it is blue or green color is observed, then the presence of nitrogen is confirmed. So detection of carbon, hydrogen, and next one is nitrogen. Carbon, hydrogen, nitrogen. Next, okay, sulfur is also what? But sulfur, in this case, sulfur. Next heading, detection of sulfur. Detection of sulfur. Detection of sulfur. So here, two tests. Number one, sodium nitroprusside and lead acetate. Sodium nitroprusside test. Sodium nitroprusside. Sodium nitroprusside test. First one. Whereas the second one is lead acetate. Lead acetate test. Sodium nitroprusside. So here, sodium nitroprusside gives violet color with sodium nitroprusside. So here SFE, sodium fusion extract. So this sodium fusion extract, if you are adding a few drops of sodium nitrochloride, if it gives a violet color, this indicates the presence of sulfur. Sulfur is present. Sulfur is present. SFE, sodium fusion extract with sodium nitrochloride. It gives violet coloration. So this indicates the presence of sulfur. Sulfur is present.
We have to keep the solution.
Just only SFE. You have taken the SFE. Add few drops of sodium nitrochloride. If violet coloration immediately, that indicates the presence of sulfur is confirmed. Second one is lead acid test. So here, first take SFE, sodium fusion extract in one test tube, and add lead acetic acid plus lead acid. First, it is acetic acid ACOH, CS3COOH, acetic acid plus lead acetate, PbACO taken twice, lead acetate. Pb in bracket CH3CO taken twice, CH3COO acetate, CH3COO acetic acid, complete formula COOH, and this is Pb CH3COO taken twice, lead acetate. Upon adding this, if it gives black precipitate, black PPT, this indicates the presence of sulfur. Sulfur is confirmed. Sulfur is confirmed. So detection of sulfur by using sodium nitrochloride or lead acetate test. Lead acetate test. So lead acetate, sodium fusion extract, it is acidified with acetic acid and lead acetate is added. Simple one. Testable sodium fusion extract, sulfur, acetic acid, and then lead acetate. If black precipitate, sulfur is present. Sulfur is present. Next, detection of halogens. Detection of halogens. Detection of halogens. SF plus ACMO. But before adding the HNO3, it is boiled with concentrated HNO3 plus each, and then NO3 is added. Observations. First observation: white PPT. Yes, white PPT soluble in NH4 OH, ammonium hydroxide. Then this indicates the presence of chloride ion is present. Chloride ion is present. Suppose in this place, pale yellow PPT, pale yellow precipitate, which is partially soluble in ammonium hydroxide, then this indicates bromide ion is present. It is pale yellow. Suppose if you are getting a dark yellow, yes, dark yellow PPT, and which is insoluble in ammonium hydroxide, this indicates the iodide ion is present. Simple experiments. Solution, that is the sodium fusion extract plus silver nitrate. Immediately check the observations. What you are getting? Precipitate, white PPT or yellow PPT or dark yellow. If you are getting white PPT, then confirm. Add with ammonium hydroxide. If it is soluble, chloride is confirmed. Chloride is present. If it is partially soluble, that must be a pale yellow PPT, which is partially soluble, bromide is present. Dark yellow insoluble, iodide is present. It's not always. Halogens. Next, detection of phosphorus. Next one is for phosphorus. Detection of phosphorus. First, the organic compound containing organic compound which is oxidized with a peroxide, sodium peroxide, organic compound which is oxidized with sodium peroxide, and then it is heat with concentrated HNO3. When it is oxidized, some precipitate is obtained. Organic compound, when it is oxidized with sodium oxide, sodium peroxide, which gives some precipitate which is filtered, and to this filtrate concentrated HNO3 is added. First organic compound is taken, to this some peroxide is added, oxidizing agent, which oxidizes to give some precipitate which is filtered. Now to this filtrate concentrated HNO3 is added, concentrated HNO3, and to this heat filtrate plus concentrated HNO3 heat, and to this ammonium molybdate is added. Ammonium molybdate. First organic compound is taken in the test tube. To that an oxidizing agent is added. Sodium peroxide is added, which oxidizes to give some precipitate. To that precipitate, we are going to add concentrated HNO3 is added and it is heated. And after that, add in ammonium molybdate. So after adding this, you will get an precipitate. Yellow PPT, no? Yes, yellow precipitate is absorbed in this. If you are getting yellow PPT, this indicates the presence of phosphorus. Yellow precipitate, phosphorus is present. Organic compound oxidized by an oxidizing agent and then added concentrated HNO3 and ammonium molybdate. If it gives yellow PPT, that indicates the presence of phosphorus. And lastly, oxygen. There is no particular method to detect the oxygen, but simply we can confirm the presence of oxygen by confirming or by checking the functional groups like alcohols, phenols, ether, aldehyde, ketone, carboxyl, oxygen containing functional group. OH. If alcohol is present, that means oxygen is present or not? Yes, oxygen is present. Suppose if the compound is aldehyde, if it is ketone or carboxylic acid, or the compound containing nitrate group, etc. Nitro compounds. So in these cases, oxygen is present, but there is no specific method to determine or to detect the presence of oxygen, but indirectly it is detected. If the presence of any functional group which containing an oxygen is present, oxygen containing functional group is present, that indicates the presence of oxygen. So by indirect method, we can detect the presence of oxygen. So these are the qualitative analysis of organic compound. So detection of various elements present in the organic compound. ಏನಿಲ್ಲ ಟೆಸ್ಟ್ ಇದೆಲ್ಲ ಟೆಸ್ಟ್ ಮಾಡಿ ನೋಡ್ಬೇಕಷ್ಟೇ. Organic compound, ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ organic compound, and then further test. Check the observations and confirm information. Inference. Experiment, observation, inference. Yellow PPT partially soluble in ammonium hydroxide, bromide. Dark yellow PPT insoluble in ammonium hydroxide, iodide. For halogens. Yes, next study is quantitative analysis. Fluorine barium. ಅದಕ್ಕೆ ಮಾತ್ರ ಸ್ಪೆಸಿಫಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ಗಳಿದಾವೆ ಪರ್ಟಿಕ್ಯುಲರ್. Quantitative analysis. Qualitative. Next one is quantitative. Quantitative analysis. Quantitative analysis involves the determination of percentage of various elements present in the compound. Percentage, quantity of element. Quantitative analysis. So here we are measuring the amount of different or various substance or various elements present in the given compound. So same, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, halogens, etc. How much element is present in the given organic compound. Quantitative. So first one is analysis of carbon and hydrogen. The quantitative analysis of carbon and hydrogen by Lebig's method. Lebig's method. First one, analysis of carbon and hydrogen. Carbon and hydrogen. See, detection of carbon and hydrogen. Carbon and hydrogen. Simply organic compound is heated and the tube is connected to heating tube is connected with a delivery tube which containing calcium copper sulfate and another end is dipped in the lime water. So here same we can take the same apparatus or some different. So here in this Lebig's method, one is heating tube. This is connected with the organic compound is heated with copper oxide and this is connected to an previously weighed U-shaped tube. This is connected to an U-shaped tube which containing U-shaped tube. Two U-shaped tubes are connected in series and it is connected to the heating tube. The one U-shaped tube contains anhydrous calcium sulfate CaSO4 anhydrous. In the previous case, we have taken copper sulfate. We can take copper sulfate also, no problem. And another containing KOS solution, aqueous KOS solution. Lime water, we can take lime water also, no problem. So in these two cases, these are the two U-shaped tube. Separate. These U-shaped tubes are filled. One is filled with anhydrous calcium sulfate, and other one is filled with aqueous KOH solution, and these two are connected in series and it is connected with the heating tube. Now, initially it is previously weighed. What is the mass of this U-shaped tube? Mass of U-shaped tube is, let us say, its initial mass is the M1, initial mass is M1, its mass is M2, initial mass of U-shaped tube which containing anhydrous calcium sulfate and aqueous KOH solutions are M1 and M2 respectively, initial mass. Now when it is connected to the heating tube, so in the heating tube, let us assume that let W be the mass of organic compound I have taken. How much? W be the mass of organic compound I have taken, and it is mixed with copper oxide plus organic compound. So compound W gram of organic compound is mixed with copper oxide and it is heated. What happens when it is heated? When the organic compound is heated, what happens? Yes, the compound which contains carbon and hydrogen. So carbon, when it is combining with copper oxide, gives rise to carbon dioxide. Carbon dioxide, one carbon, two oxygens. So this is the equation. It containing hydrogen, when it is combining with copper oxide, gives rise to water. So these are the gases. These two gases are passed through these U-shaped tube. What happens in this case? Carbon dioxide do not react with this. Carbon dioxide do not react with this. So only water molecules will be passed through this. So these water molecules are absorbed in this. Water molecules completely is absorbed because it is anhydrous. It do not contain any water molecule. So all the water molecules are absorbed in the anhydrous calcium sulfate. So when water molecules are absorbed, its mass is increases. Initially its mass is M1. Now after the reaction, its mass is increased more than M1. So now remaining gas, that is carbon dioxide, when it is passed through KOH solution, it absorbs. KOH solution absorbs the carbon dioxide. So its mass also increases. After the completion of reaction, again weigh the mass of U-shaped tube. Let us assume that the mass of U-shaped tube after the experiment is, let's call it as M3 and M4. M3 and M4. Why the mass increases in this case? The mass is increased due to absorption of water. In this case, absorption of carbon dioxide. So, how much water is produced during the reaction? Good. So, the increase in the mass is due to water molecule. Therefore, the amount of water produced in this reaction is given by the difference between the mass, that is M3 minus M1. Let's say it is W1, or difference. Next, how much carbon dioxide is produced?
M4 minus M2.
M4 minus M2. So here, let W be the mass of W gram, be the mass of organic compound taken initially. Let the mass of water produced during the reaction is equals to, let us call it as W1. This is given by mass of water M3 minus M1. This gives the mass of water produced. Similarly, the mass of carbon dioxide produced is given by W2, that is equals to M4 minus M2 gram. Correct? Yes, over. This is the experiment. Now remaining is stoichiometric calculation. Now look at this. Estimation of carbon. Estimation of carbon. First one. Estimation of carbon. Carbon estimation of carbon dioxide is producing in this reaction. So 1 mole of carbon dioxide is produced. Then how much carbon is present in this? 1 mole of carbon. So 1 mole of carbon dioxide containing 1 mole of carbon. So what is the mass? In terms of mass, 44 gram of carbon dioxide is produced during the reaction. That indicates 12 grams. Correct? Now during this experiment, how much carbon dioxide is evolved? Carbon dioxide, that is W2. Shall I write W2? Yes. So for 44 gram of carbon dioxide, 12 gram of carbon is present. So for W2 gram, how much carbon is present? Yes, how much? The mass of carbon in the given organic compound is equals to 12 by 44 into W2. Then what is the percentage? Percentage of carbon is equals to 12 by 44 into W2 into 100 divided by total mass. Total mass is to W. Mass of carbon. If 1 mole of carbon, 44 gram of carbon is produced during this experiment, that indicates how much carbon is present? 12 gram of carbon is present. So 12 gram of carbon is present in which? 12 carbon is present. Where it is present? In the given organic compound. So how much mass, how much compound is taken in the heating tube? W gram. So it is not given. So percentage mass of that element divided by total mass of the compound into 100. So mass of this element, let's call it as X. This is equals to some X gram. X. So percentage X by mass of carbon divided by total mass into 100. Clear? So this is the percentage. Percentage of carbon present in the given organic compound. Similarly, estimation of hydrogen. Can you estimate? Estimation of hydrogen. Yes, 1 mole. 1 mole of H2O is equivalent to 2 hydrogens. In terms of mass, 18 gram of water contains 2 grams of hydrogen. Now in our experiment, W 1 gram of water containing how much? So the mass of hydrogen is equals to 2 by 18 into W. Let us call as Y gram. Then percentage. That's good. The percentage of hydrogen, the given compound is directly Y by W into 100. So Y by W into 100. This is the percentage. Note this formula, final formula. Formula is required. Estimation of carbon and hydrogen. Estimation of carbon and hydrogen. Very simple. For carbon, percentage of carbon is equal to 12 gram is present in 44. Then how much is present in the given mass? Total is W into 100. For hydrogen, 2 gram is present in 18 gram. So how much is present in water? W1 is for water, W2 is for carbon dioxide. So W1 how much? W into 100. Percentage of carbon and hydrogen. Estimation of carbon and hydrogen. Estimation of carbon and hydrogen. Beta? Right, next. Estimation of nitrogen. Estimation of nitrogen. Here these two methods are there. One is Dumas method and Zeldar method. Estimation of nitrogen by Dumas method and Zeldar method. Estimation of nitrogen, estimation of halogens, sulfur, phosphorus, and oxygen. This completes the topic. Estimation of nitrogen. Agree. Estimation of nitrogen, estimation of halogen, sulfur, phosphorus, oxygen. All the estimation. So for nitrogen, two methods are there. Estimation of nitrogen by Dumas method and Zeldar method. Estimation of nitrogen. Number one, first one by Dumas method. Zeldar's method. Estimation of nitrogen by Dumas and Zeldar method. These two concepts will continue the next class. Second. Continue. Yes. Spirit will right. First one, Dumas method. Not only the heading. Estimation of nitrogen by Dumas method. Estimation of nitrogen by Dumas method. Estimation of nitrogen by Dumas method. The organic compound is heated in the presence of copper oxide, the copper gas, and the gases produced in this is made to pass through Skips nitrometer. Skips nitrometer. Skips nitrometer, and this is connected with a reservoir. This is connected with a reservoir. Reservoir. Now, this is filled with mercury. Skips nitrometer. Just to avoid the backflow of gases and discontinuing KOH solution. KOH solution skips nitrometer. So here this is initially okay, it's closed. Like this. Closed. Initially, the volume of nitrogen gas. So first, the solution is up to here. In the heating tube, heating vessel or heating apparatus, the given organic compound, let us W gram of organic compound is taken in the heating flask and it is heated in the presence of copper oxide. Copper oxide. What happens? The organic compound containing nitrogen is heated with copper oxide. So suppose carbon present in the organic compound is oxidized to carbon dioxide. The carbon present in the organic compound is oxidized to carbon dioxide. Hydrogen present in the organic compound. Hydrogen present in the organic compound is converted into water. And then the nitrogen. If any nitrogens are present, which sets free. So here N2 are produced. If any nitrous oxides or nitrogen oxides, any oxides of nitrogens are produced during the reaction, oxides of nitrogen, which further react with the copper oxide, gives rise to dinitrogen, N2. So during these reactions, when it is heated with copper oxide, we are getting carbon dioxide, water, and nitrogen gases. The given organic compound containing nitrogen is heated with copper oxide in the presence of or in the absence of carbon dioxide. In the absence of carbon dioxide. So here, all the carbons which is present in the organic compound are oxidized to carbon dioxide. Hydrogen is oxidized to water, and nitrogen is set free into alcohol. And these gases are made to pass through a Skips nitrometer. When it is passed through Skips nitrometer, water and carbon dioxide are absorbed by KOH solution. This is KOH. Water molecules and carbon dioxide are absorbed, and the remaining gas, that is N2, which do not react with the KOH solution, which is collected in the Skips nitrometer. So how much nitrogen gas is collected, that is measured. The volume of nitrogen gas produced during this reaction is measured by using Skips nitrometer. Skips nitrometer. So this is the experimental apparatus. Experimental. Here given organic compound is taken in the heating flask and it is heated with copper oxide. So during this process, carbon is oxidized to carbon dioxide, hydrogen to water, and nitrogen get free. So these three gases are made to pass through Skips nitrometer. It is mercury, which prevent the backflow of solution. So here these gases will pass through the potassium hydroxide solution. Carbon dioxide is absorbed, water is also absorbed. Only N2 gas is collected in the Skips nitrometer. So the volume of nitrogen liberated during this process is measured by carefully observing or adjusting this reservoir. While measuring the volume, the level in reservoir and the Skips nitrometer must be same. So volume change same. The level of solution in reservoir and Skips nitrometer must be same while measuring the volume. Now I have measured the volume of nitrogen collected. This is the room conditions. At normal temperature and pressures, I have measured the volume of nitrogen collected. This is the experiment 4. Next is remaining estimation. Now at our room temperature, we have measured the volume. Temperature is normal room temperature. What about the pressure? The pressure is due to here. Pressure, total pressure obtained is due to, in this case, the pressure exerted is due to nitrogen plus nitrogen plus water aqueous, because some of the water vapors are also produced. There will be chances of exerting the pressure. So the total pressure exerted is equals to the total pressure Pressure due to nitrogen is equals to total pressure minus aqueous pressure. Total pressure exerted is because mixture of carbon dioxide plus water plus nitrogen, all are gases. So these gases are collected here. Usually, preferably, this will absorb water and carbon dioxide. So the total pressure exerted by the nitrogen is equals to P minus A, where A is aqueous pressure or aqueous tension. Now, temperature is T. Now convert this volume to standard conditions. Convert this volume to standard condition. See, at room temperature, P1, T1, P1. P1, T1, P1. Pressure is P minus A. Temperature, that is the room temperature T1. Volume is, we are getting P. Convert this volume into standard conditions. Standard conditions P2, V2, T2. P2 is 760 mm standard pressure, 1 atmospheric pressure, 760 mm. Temperature is 25 degree, 298 Kelvin. And what is the volume? Question. So you have the formula P1, V1, T1 is equals to P2, V2, T2. Substitute and simplify. So therefore V2 is equals to P1, V1, T2 divided by T1, V2, T1, P2. Room temperature is taken as 25 degree. Correct? Okay. P1, P1, P2 divided by T1, P2. P1 means it is substitute these values. V2 is equals P1 is P minus A. Experimentally it is determined. Next, V1, this is the volume V we have measured during this experiment. T2 is standard 298, 273 now. At STP condition 273, 0 degree divided by T1, that is room temperature as it is, and pressure P2. P2 is 1 atmosphere, 760 mm. Yes, simplify this. After substituting, we have simplified. Let us take this value as x ml. The volume of nitrogen collected at STP is x ml. X ml. Over. Remaining is stoichiometric. Next, suppose if you are getting 22.4 liter or 22.4 ml of nitrogen, then that indicates 1 mole. 1 mole of any gas which occupies 22.4 liters. So if we are 100 ml, then this indicates 1 mole of nitrogen. Then its mass is 28 liters. Good. So how much we are getting? X ml. So for x ml, what is the mass? What is the mass? So x into, so 28 into x divided by double to 400. This is mass of nitrogen. N2. It is for N2. For single nitrogen, just only 14, so divide by 2. So if you are taking N2 molecules, take 28. Or simply take 14 for nitrogen, single nitrogen. 22.4 liters of nitrogen. Nitrogen is gas, N2, therefore I have taken 28 gram. For single nitrogen, just divide by 2 again. Divided by 2. So 22.4 x divided by 22.4 liters. For N2, it is the mass of N2. If you want only single nitrogen, divide by 2. It is 14. 14 28. 28. So for N2. Then what is the percentage? So this is the mass of nitrogen present. Percentage by 100 into 100 divided by W. Divided by W. Into 100 divided by total mass of the organic compound. This is the mass method. So first, what is the experiment? The given organic compound containing nitrogen is heated in the presence of copper oxide, where carbon is oxidized to carbon dioxide, hydrogen to water, and nitrogen get free. These gases are passed through Stiff's nitrometer and measure the volume of nitrogen collected at the room temperature and convert that volume into the standard STP conditions, and by that STP we get estimate. Next is the yes.